Good morning, everybody, and I hope you're having a great day. Today, we are going to continue talking about types of rocks, which you were introduced yesterday. And to start with, it would be helpful for you to take out your vocabulary map that you were working on yesterday. Then you'll have access to information about these words that we're going over, which I think will be very helpful for you as we read this article. So if you have your vocab map out, we will continue learning about the rock cycle. So we learned about this yesterday. There are three types of rocks. We've got metamorphic, we've got igneous, and we've got sedimentary rocks. And they all are different, but they are all related to one another. That's why it is a cycle. Just as a reminder, metamorphic rocks are formed when minerals and rocks are changed underground by heat and pressure. They are formed deep within the earth. Igneous rocks, these are melted rocks that have been cooled and solidified. They're created when magma, that is lava, becomes cool. So these rocks are often shiny or glossy, and they are related to volcanoes. Finally, sedimentary rocks. So these are formed on the surface of the earth from layers. So they're made of particles that we call sediments, such as sand, clay, skeletons from sea animals, shells, things like that. They all form together, they get crushed together and create layers of sediments. So we're going to go into some more detail about this. That was just a quick review, but I hope you remember some of it from yesterday. And we are going to read this article. And this article is called How to Identify the Three Major Types of Rocks. This is written by Andrew Alden, and this comes from News ELA, which is a great website, very helpful. You can change the leveling, so if it's too hard for you, you can make it a little easier, which is a great tool to have. So let's look right here. Let's look at the picture we have. This says, this is an outcrop of igneous rock in Iceland. Igneous rock is created by volcanic activity. So that would be extrusive igneous rock because it's extruding or coming out from the earth. So that would be called extrusive. And that is different from intrusive igneous rock, which would be inside of the earth. That's just a little bit of a side note. So as I start reading, I want you to remember to annotate and take your own notes. If you are on the News ELA website, there is a built-in annotation and highlight feature if you choose to complete the reading that way. If not, you can use a paper copy if you have a printer at home and you're able to print it out. I know that is not a possibility for everybody. So just remember, when you're annotating a text, that means something besides just highlighting everything. If you start highlighting everything, that indicates to me that you think everything is important. Now, how can we really nail down what's truly important if everything is important, right? So you want to make sure that you're putting your thoughts next to what you highlight. So I will show you an example of what I mean by that right when we start reading the first section. So again, the title of the article is How to Identify the Three Major Types of Rocks, and it is by Andrew Alden. And let's start, and I'm going to show you how I would annotate. In geology, pictures of rocks can be used to help you best determine which of the three major types of a particular rock belongs to: igneous, sedimentary, or metamorphic. By comparing your rock sample with photographic examples, you can identify key characteristics such as how the rock was formed, what minerals and other minerals it contains, and where the rock may have come from. So if I was going to annotate this part right here to help me figure out what the main idea of this entire article is, I might note this: pictures of rock can help you best determine which of the three major types a particular rock belongs to. And then maybe I would link this to this. Because I'm saying I'm able to compare my rock sample and figure out key characteristics based on the photo. So I might make a little line here to show that these are linked. But another thing you might do when you're annotating is note words you don't know. So let's look at the next paragraph, starting right here. Excuse the bell. Sooner or later, you're bound to encounter hard, rock-like substances that aren't rocks. So what about this word encounter? What if I've never heard that before? I might have to go look that up, right? So that would be where I would do that. But in this case, encounter means to come across or to find. You may encounter rocks in your backyard. You may encounter them on the road, something like that. I'm going to continue reading right here. Such items include man-made substances like concrete and bricks, as well as rocks from outer space, such as meteorites that have dubious origins. Now again, I might take this word dubious and circle it. And that would say to me that I need to go back and look that up in the future. Before beginning the identification process, make sure that your sample has been washed to remove dirt. You'll also want to make sure you have a freshly cut surface so you can identify color, grain structure, stratification, texture, and other characteristics. So I might circle this word stratification because I don't know what stratification is, but I need to know that in order to properly understand this article. So the next section is called igneous rock. The title is here, but it's actually going to continue here. Now, my goal for you at this point is to try to annotate as I read on your own. I will still continue to point out some things that are important, but I'd like to see what you're able to do on your own. You can note anything that you're uncertain about. You can note anything that you think is really cool or anything that you want to learn more about in the future. So I'm going to start reading again right here. And that is on the second page of the new CLA article if you have a hard copy or are scrolling through it as a PDF. Igneous rock is created by volcanic activity. These rocks come from magma and lava as they cool and harden. Igneous rock is most often black, gray, or white. It often has a baked appearance. Igneous rock may form crystalline structures as it cools. This gives it a granular appearance. If no crystals form, the result will be natural glass. Examples of common igneous rock include basalt, granite, and obsidian. Basalt is formed from low silica lava. Basalt is the most common type of volcanic rock. It has a fine grained structure and is usually black to gray in color. Another type of igneous rock is granite. This rock may range from white to pink to gray, depending on the mix of quartz, feldspar, and other minerals it contains. It is among the most abundant type of rock on the planet. Obsidian is a type of igneous rock that is formed when high silica lava cools rapidly. This forms volcanic glass. It is usually glossy black in color, hard, and also brittle. This is a picture of the entire rock cycle right here, and I am going to go back to that after we finish reading the article. Sedimentary rocks. Sedimentary rocks, also called stratified rock, is formed over time by wind, rain, and glacial formations. These rocks may be formed by erosion, compression, or dissolution. Sedimentary rock may range from green to gray or red to brown, depending on iron content, and is usually softer than igneous rock. Examples of common sedimentary rock include bauxite, limestone, and halite. Bauxite is usually found at or near the Earth's surface. This sedimentary rock is used in the production of aluminum. It ranges from red to brown with a large grain structure. Limestone is formed by dissolved calcite. This grainy rock often contains fossils from the ocean because it is formed by layers of dead coral and other marine creatures. It ranges from cream to gray and green in color. Halite is more commonly known as rock salt. This sedimentary rock is formed from dissolved sodium chloride, which forms large crystals. And you can see in this picture here, you can kind of see that there's layers in this rock. Like I can see this right there, it's darker, and right here is darker. And you literally right here, you can just see that it's like layers and layers. I just think that's kind of cool looking. Metamorphic rocks. Metamorphic rock formation occurs when sedimentary or igneous rock becomes changed or metamorphosized by conditions underground. So that's important. Changed, metamorphic, metamorphosized. That metamorphic, that means change. So think about that. The four main agents responsible for metamorphosizing rock are heat, pressure, fluid, and strain. All of these agents are capable of acting and interacting in an almost infinite variety of ways. Most of the thousands of rare minerals known to science occur in metamorphic rock. Common examples of metamorphic rock include marble, phyllite, and serpentinite. That sounds like a snake. Marble, think about like a really fancy counter in a kitchen that might be made out of marble. Marble is a coarse-grained, metamorphosed limestone. It ranges in color from white to gray to pink. The colored bands, called veins, that give marble its characteristic swirled appearance are caused by mineral impurities. Phyllite is a shiny, colorful, metamorphosed slate. It ranges in color from black to green-gray. It is recognizable by the flakes of mica it contains. Serpentinite is green, scaly rock. It is formed beneath the ocean as sediment is transformed by heat and pressure. So that was the three main types, and there's just a little final paragraph here to help sum it up. Just because a sample looks like a rock doesn't mean it is one, however. For example, meteorites are usually small rock-like formations cast from outer space which survive the trip to Earth. Some meteorites contain rocky material in addition to elements such as iron and nickel. Others are comprised solely of mineral compounds. Concretions resemble smooth, often oblong masses. They are found along riverbeds, seemingly cemented together. These are not rocks, but rather masses formed by dirt, minerals, and other waterborne debris. Fulgurites are hard, jagged, oblong masses formed by soil, rock, and sand that have been fused together by a lightning strike. Geodes are sedimentary or metamorphic rocks containing a hollow, mineral-filled interior such as quartz. Thunder eggs are solid, agate-filled lumps found in volcanic regions. They resemble geodes when opened. So that last part was just some interesting information about things that may look like rocks, but actually aren't. They're made up of something else, such as quartz, or they've been fused together by lightning, or it's made of dirt, minerals, other things like that. So that's just a little side note. But let's just take a second and go back and look at the rock cycle. So this is the picture from the News ELA article, and it shows the relationship, and it's important to pay attention to the direction of the arrows because that shows which rocks become other rocks and in what way. So for example, if we have a metamorphic rock right here, if it were to melt into magma and then crystallize, so that would mean it would get hard again, it would then become igneous rock, okay? So pay attention. You can look at the entire rock cycle like that based on this little graphic here. I also really like this graphic because it shows it in relationship to the earth. So for example, right up here, it shows the weathering that leads to debris falling, which leads to sedimentary rock. And then once it's sedimentary rock and it goes beneath the earth and gets buried and there's high temperature and lots of pressure, it becomes metamorphic rock. And it's under the earth right now. Then it melts, and the magma can either be in a volcano and explode, or it'll crystallize and raise above the earth into igneous. And then the igneous rock on the earth, which would be like this mountaintop here, gets weathered down and becomes sedimentary again. That's a lot, and I realize this. If you would like to take a minute and look over this cycle without my notes on it, you can. Definitely pay attention to the direction of the arrows. They are very important. So the final step for you is to complete the News ELA quiz. So you're going to do that on your own. You can go back to this video and listen to me again. You can go back to the sections and hear what I have to say while you're answering it. That is totally fine, but I want you to try it on your own. That is your independent work after you close out of this video. So just to remind you, today we have read the News ELA article, How to Identify the Three Major Types of Rock by Andrew Alden. The graphic of the rock cycle is really useful and can help to understand and identify the relationship of the three major rock types. Next class, you will be completing the vocabulary map that you had begun yesterday, and you may use this article and your annotations to assist you. We will also go over the quiz, make sure that's all good, and I can help clarify any questions you might have about that. Thank you to everybody. I hope you have a great day, and I will see you all tomorrow. Bye.